Christian, thank you. Muy buenos días a todos. Bienvenido a la conferencia. Es un placer para mí estar con ustedes ese día. Christian didn't know this, but I changed the title of the presentation a little bit. We at Boeing are very, very excited about the future of aerospace. I wanted to tell you about some of the reasons why we're excited about aerospace today. I want to share some of my experiences that I've had over my career and even going back to my educational time, and also talk about where we think the future is going in aerospace. So this is kind of a map of where we're going to be talking this morning. I wanted to find out who is attending today. How many of you are students? Bueno, casi la mitad. Muy bien. How many are professors or officials at universities? Lo demás. Muy bien. How many are government officials, representatives of? Very good. And industry partners, suppliers? Lo demás. Well, welcome. It's very good to have you. I hope there'll be something in this presentation that's of interest to you and that will help you think and look forward to the future like we think it will shape up. I wanted to first talk about aerospace in Mexico. The history goes back more than 100 years in the country. Figuring out the buttons here. All right, laser pointer's not working. If you look at those top pictures, some of you may have heard of Charles Lindbergh. He was a famous American aviator. He was the first to cross the Atlantic. Right next to him is Emilio Carranza. You notice those aircraft are very similar. They're both Ryan aircraft. They were both purchased about the same time. Charles Lindbergh and Emilio Carranza were both contemporaries and became good friends. In 1927, Charles Lindbergh flew a goodwill flight from New York City to Mexico City. The following year, Emilio flew from Mexico City to Washington, D.C., was well received there and spent some time there, and then went on to Mexico City. So there's a history there that goes back many years. I want to take some time to talk about Boeing and Mexico, our relationship. That goes back almost 60 years. And then a market forecast. This is one of the reasons why we at Boeing are very, very excited about the future. I'll talk some about materials and technologies and about the next 100 years, where we think things will be going. That top picture shows Boeing's first commercial product. It was a seaplane built in Seattle by Bill Boeing. Bill Boeing, at the time, there was many people that were starting to fly. They would fly aircraft around the country. They would stop. If you had a few dollars, you could go pay the pilot and he would take you up and fly you around for a little while. Well, Bill Boeing did this a couple times, and after looking at those aircraft and seeing how they worked, he thought he could build a better aircraft. So he did. In 1916, he produced that aircraft in Seattle. The picture on the bottom shows our latest commercial aircraft offering, the 787. That entire fuselage, the wings and the tail segments are all carbon fiber. There's a drastic acceleration of technology represented there. That represents having Boeing in Seattle for 100 years has had an effect on the community and what is found in that area and the capabilities that are there and the prosperity of the area. I grew up in California, and so I wasn't necessarily integrated into an aerospace type of a culture. My first introduction came when I was a student at BYU. One of my best friends said, "Hey, I heard about a convention that's happening. It's called SAMPE," and I didn't even know what SAMPE stood for. So we decided that we wanted to find out if we could go to this convention. So he talked to his professor, and I talked to one of my professors, and they got permission for us to rent a car and drive 6 hours from where we're going to school in Utah to Nevada. And we attended this conference, and we walked into a building this size, and it was filled with material suppliers and aerospace companies and researchers and university professors and students, we walked around wide-eyed and amazed at what we saw there. And I was excited. And I knew I wanted to be in composites, but I didn't know if I wanted to be in automotive composites or medical composites. At that point, I knew I wanted to be in aerospace composites. So I finished my training and got hired at Boeing. And when I got to Seattle, I hadn't ever been to Seattle before. We pulled into the city, and from the beginning, it was apparent that there was a large aerospace culture there. Within 15 kilometers of my house, there are 3 airports large enough to land and take off jet aircraft. One of those airports, I work within about 100 yards of one of those airports now, today. That airfield is 5,000 meters long. It's an alternate shuttle landing site. It's big enough to land space shuttle there. So, in and around Seattle, aviation is in the blood, it's in the culture. There's suppliers, there's families, even in families. There are 3rd and 4th generation families whose parents and grandparents and great-grandparents worked at Boeing during World War II, during the Korean War, during the Vietnam War, during the difficult times and during the good times too. So that has had an effect on how Seattle has developed and also on how Boeing has developed. Now, when I started preparing for this conference, I started looking at how aerospace has developed in Mexico, and I see something very exciting here. You're aware of clusters and how those are developing. As I looked at what's going on, seeing the history of Baja California going back 60 years in aerospace, they've been supplying parts and materials for aircraft industry for many, many years. So that was kind of the core of the formation, and then it spread to the other 5 clusters. But what I thought was interesting is these numbers on the screen represent aerospace companies in those other states, and you can see that it's starting to spread and grow also. That's a very good sign. So as I said, Mexico has been a customer for Boeing products and Boeing-related products for more than 50 years. All Aeromexico aircraft that have more than 100 seats are Boeing aircraft. The small picture in the upper right-hand corner shows Aeronaves, Boeing Douglas DC-3, going back many years. Aeronaves later became Aeromexico. Aeromexico received their first 787 back 3 years ago, or 2 years ago. It's painted in the Quetzalcoatl livery paint scheme. This is a beautiful aircraft. Boeing Flight Services has a training facility at the Aeromexico training campus in El DF. And we have supplier quality reps on site in Chihuahua and Sonora. And we've provided satellites to the country of Mexico since 1985, 33 years. Now, this is another reason why Boeing is very excited about the future. This is our forecast looking out 20 years. Forecasts the need for 42,700 new aircraft. Those will be worth more than $6 trillion. I don't even know how much that is, but I know it's a lot of money. So we forecast about 70% of those or 31,000 of those aircraft will be narrow bodies, and about 9,000 of those will be wide bodies aircraft. And that's just the commercial, the passenger and cargo variants of those aircraft. From all indications, that trend will continue to grow. The vertical axis represents revenue passenger kilometers. The trend since 1980 and going up into the future represents a trend upward, which we think will continue, at least 3.5%. So what we do today. Boeing commercial aircraft, we have a 7 series of commercial aircraft. Some of those are out of production, but our current offerings are 737, 747, 767, 777, and 787. And there may be more being announced here in the very near future. Defense, space, and security. We're the world's largest manufacturer of military aircraft and satellites. We provide services for NASA and large-scale system integration, worldwide system integration. Boeing Global Services, on the right-hand side, that represents a new business unit for Boeing, started in 2016. We forecast that the revenues generated by the Global Services division will be equivalent with the other two divisions within a few years. That's a very lucrative market that we've just begun to enter, and that's been very successful so far. And then there's Boeing Capital Corporation that provides financing services for Boeing's customers. So a few more numbers. Last year, in 2017, Boeing's revenues were $93.4 billion. We have customers in 150 countries. We have contracts with more than 20,000 suppliers around the world. Boeing has about 140,000 employees across 65 countries in the world. And about 70% of our revenues come from countries outside the United States or international customers. And here's some pictures of a few of our current products. That's the commercial airline aircraft across the top. The military aircraft have early warning and radar aircraft, tankers, strike systems, fighter aircraft, weapons, rotorcraft, the Apache, Chinook, some unmanned systems. This MQ-25 on the right-hand side is a very interesting one. There was just a contract announced by the Navy a few weeks ago. That is an unmanned aerial refueling vehicle. It's intended to be carrier-based, and it's very interesting to see what that will drive. That comes with a whole host of supporting technologies that have to be developed to make that possible. So that's going to drive a lot of innovation and a lot of learning on our part, and will help us advance in that field of autonomous vehicles. In network and space systems, we provide satellites, space launch, missile defense, networking systems, and intelligence security systems. And then our global services provide various kinds of upgrades, repairs, global services and support, training systems, and so on and so forth. So Boeing is widely spread now, after starting with one aircraft made of spruce, covered with canvas and painted, a float plane. Over 100 years has generated products in all of these fields where customers had needs, and we had a certain level of expertise, and decided in many cases to expand that expertise to be able to cover a new product or introduce a new product, and it's helped us grow. Now, what I just mentioned was the key point of technology in helping that advancement happen. Without technology, we would still be producing spruce aircraft covered with canvas and painted, flying 55 miles an hour. This curve kind of represents the growth of technology in general and the application of that, which then spawns more technology. So we anticipate that curve will get steeper and steeper as applications continue to grow and as technology becomes more available to drive those products and services. Okay. I'm kind of a technology geek, so this is really cool to me. These are the areas we've divided up where we do research into domains. That helps us keep track of the research that we do to make sure it's applicable to our current product lines or future product lines. And it keeps us from expending funds or resources on areas that may not necessarily be beneficial to our product lines. So I was going to talk a little bit about each of these areas, kind of give you an idea of what we do in each of those areas. The platform systems and subsystems, the goal is to provide a competitive advantage through the addition of features and functionality for platform systems. The platform performance domain, these are all research domains. They enable development of advanced affordable platforms with superior performance. It creates a competitive advantage and a greater value for our customer. The objective of this domain is to align research in areas that influence overall vehicle performance, including concept configuration, development, aerosciences, propulsion, guidance, navigation and control, flow control, computational sciences, and advanced conceptual design processes. The structures domain covers 4 key areas of technology: cross-functional architecture. So you've got a structure that provides your air vehicle, your airframe. Can you incorporate any other technologies into what's structural to increase the usefulness of that structure? Maybe incorporating an antenna into a structural part of the vehicle. The second area under structures is interiors and architectures. It helps us make more efficient airframes and interiors. The third area under structures is material and process technologies. We develop those with suppliers, including composites, metals, and ceramics. And who knows what will come next as far as materials. Hybrids probably of some of those materials. And the fourth area under structures is methods, tools, and validation. That helps us replicate those technologies across the enterprise. Our manufacturing domain focuses on developing key processes that helps us be more efficient in the manufacture of our products. Cybersecurity domain has responsibility for providing secure network systems, intelligent information and knowledge, adaptive mission management, optimized decision-making, and dynamic planning with performance prediction. All of those become even more valuable as the package gets put together and capabilities are increased. The support and services domain focuses on tech data and training, material management, maintenance and modifications, things in that area. Environment and safety pioneers new technology to create environmentally progressive products. So we're concerned about, while we're doing all this, minimizing the footprint that we have as we create these products and as they're used by our customers. And finally, the systems engineering domain provides Boeing with systems engineering knowledge, process and tools to design, build, and deliver, and support complex systems that fly, float, and soar into space. There's an interesting reference there. I haven't mentioned any of our autonomous underwater vehicles, but those are products that we've developed for some of our customers. So we can provide knowledge-based system awareness from seabed to space with all of our products, and integrate all of the data that's collected by those sensors into a single system that will provide knowledge and environment management. I wanted to show you kind of where Boeing Research and Technology fits underneath all of these products and these different business units that I just talked about. We're a relatively small organization, and I'll talk a little bit more about our details, but we support all of these areas: commercial, global services, and space and security systems. So we get to be involved in really, really cool stuff, cutting edge, newest and latest, providing research. And another reason why we're very excited about the future is there are experts in some of these areas that are not within Boeing, so we're becoming partners with them. We're working with them. We're hiring work out and research with them. We're going into, in some cases, business ventures with some of those organizations or those companies. And the number of those companies, the number of those technologies is increasing rapidly. Okay, here's a few of our details of Boeing Research and Technology. We have 11 research centers around the world, 5 of those in the US, 6 throughout the rest of the world. You can see those locations there. Last year we had 293 research projects that we were working on with 472 partners, universities, consortia, or industry partners. BRNT Europe has several centers that are included under that Europe. There's capabilities in Spain and Germany and England as well. I was just looking up there. We've also stood up some centers, and I guess I needed to catch this chart up. We also have centers in Korea and Japan now as well, and we're continuing to grow. So here's a brief list of the centers and the areas of technology that they're focusing on. So for various reasons, depending on expertise of a particular university, a particular supplier, a particular region of the world, we've decided to place certain research topics in those areas. And so we're refining our focus on these particular research topics and these particular locations. As we progress, there are other areas in the world that are specializing in certain technologies. We'll be seeking those people out and seeking partnerships with them to work with them to develop more products and services for our customers. Now, in addition to we work with lots and lots of universities, but there's a few universities with which we have a very special relationship. In the case of most of these universities, we have had a very long, what started as a normal relationship with the university has been in place for a very long time, and we've continued to work with them, to do research with them, to exchange information with them, to have professors visit. In some cases, we have BOEING people go teach at those universities as guest professors. And also in some of these cases, we've partnered with some of these strategic universities to work on a product or a service for a customer. So they become partners with us in industry. In addition, we collaborate with government entities, manufacturers, suppliers around the globe, and this shows just a few of those. You can look on there and see if you have any favorites or anyone you know. This is another reason why we're particularly interested and excited about the future. There are more companies coming up into their own as technology develops, and we are seeking those companies out and creating additional partnerships with them. All right, let's talk a little bit more about the materials end of it. This is an interesting picture. I mentioned the 777 aircraft. That aircraft was produced commercially about 25 years ago. That came out, a very good airplane. We felt it was time for a efficiency upgrade on that. So we at Boeing have done some design work and have outfitted that 777 with a new carbon fiber wing and spar structure. So we've designated that the 777X. It's going to provide additional efficiencies for our customers. This is a picture of a spar tool in our plant in Everett, where we make those. That machine behind those people is something that was developed specifically for fabricating this part. This part's over 100 feet long and represents technology that we had to put in place to make it economical to use advanced materials to provide the advantages that come with advanced materials, but also in a way that is economical for the customer. Here's a few comments on the future of materials, particularly carbon fiber in aerospace. This upper left-hand chart shows a percentage by weight of carbon fiber in aircraft airframes over time. So from a very low percentage early in the history of aircraft to the upper left-hand corner shows the Boeing 787 and the Airbus A350 that are 50% or more weight by structure carbon fiber in those airframes. The chart on the upper right shows the pounds per aircraft of those carbon fibers in those aircraft. The 787 has 30 tons of carbon fiber in its construction, each airframe. And below that, you can imagine the demand that creates. We have orders for over 1,000 of those 787 aircraft. We've delivered over 700 now. At 30 tons per aircraft, there's a large demand, and that's just that one aircraft line. There's a large demand for carbon fiber. So there are carbon fiber companies that are addressing that demand. The red dots represent current production capacity, and the yellow dots, future production fiber capacity. Initially, when the composite materials were new as a technology, as a material, they were, for the most part, hand laid up. It's time consuming, it injures workers, you can't lay down very many pounds per hour. But by industrializing that and automating that, we're able to get an approach that allows us to put down many dozens of pounds of prepreg, of carbon fiber per hour. It allows us to open up possibilities with how we manufacture aircraft and what we can provide to our customers. This is another reason why we're excited about aerospace going into the next 100 years. These are 6 factors that we think will revolutionize where aerospace is going. Digitization. This is something we're beginning to use more and more. Digitization will eventually become a complete digital design of an aircraft from the beginning, including all systems. That allows us to do amazing things with how we lay out our factories, how we flow materials in and out, how we assemble, how we deliver, how we maintain those vehicles. Artificial intelligence is a whole new field of study that allows us to analyze any process that's done, from assembly, from air traffic management, to flow of an aircraft through a factory, to how our operators use and maintain their aircraft, to look for efficiencies in those that humans can't possibly find. Autonomy is the next wave of air travel. I'm sure you've heard about many of the companies that have sprung up to create UAVs that will tow people across cities or to airports. Anything from drones to passenger aircraft are being considered. All the technologies that go along with lifting 1,000 or 10,000 pounds with an electric motor and transporting it, from batteries to guidance systems to decision making, all are technologies that have to be developed to allow this to go forward. And of course, advanced materials and manufacturing. There are many, many more things to be developed and brought forward. And then the increased access to space. That used to be a government-only sort of a proposition. It's getting more and more such that private investors and individual citizens will be able to get access to space. That completely changes the economics of putting something in space and what you can do with an area above the Earth. These are things that will revolutionize the way we think about aerospace. Now, students, I want to talk to you. Jóvenes, me escuchen, por favor. This is something that you need to be thinking about right now. If any of these areas excite you or you think sound fascinating, start studying them in school or outside of school. These are places where the aerospace world will need people with knowledge in the next 100 years. You can leave your mark on aerospace as you become an expert in these areas. Attach yourself to a professor that can help you, to an industry partner that can help you. Get experience. Try to find internships. If you get into a company that's doing one of these things, and you're the best person at that company, then you will become the expert at that company, and you will have opportunities open to you. You remember how I talked about my first introduction through SAMPE to the aerospace community and the culture? Because you're here today, you're on that same trajectory. You have that opportunity to get yourself involved in those ways. So think about what excites you, what you're really passionate about. You can break ground. You can own patents. You can make developments that accelerate your company. You start your own companies that learn how to do these things better than anyone else in the world, and the world will come to you and ask for your help and your products. That is one of the reasons why we're excited about aerospace for the next 100 years. So to conclude, I hope you've thought about some things today. You had some thoughts occur to you. These are questions you might ask yourself, or there may be other questions you might ask yourself. If you're a supplier, what can you provide to the aerospace sector better than anyone else for the next 100 years? If you're an official representative of the state or the federal government, or another, what is needed to grow the aerospace culture in this area, in this country, for the next 100 years? There are lots of good models around, all around the world. You can see how that's to be done, or what has worked in the past. University representatives, professors, officials, what preparation will your graduates need to build the future of aerospace for the next 100 years? And students, what do you want to study to launch aerospace for the next 100 years? Think about these things. What do you see? I want to leave a few minutes and see if there was any questions and see what's on your mind. Why don't we, Christian, could we have someone take this microphone around the audience and I could talk from the podium here if there's any questions? Okay, Bill, thank you.
Thank you. Do you have some plans for investing in Mexico, like states or cities like Querétaro, where Bombardier has a very good presence so far?
Are these? Okay, these are on. I don't know about any specific plans, but I wanted to, what I mentioned earlier to someone, I think is very interesting. I think most of you know who the company Safran is. They have 7 plants here in Mexico, from what I understand, with 5,400 employees. They make very, very good aircraft engines. They've partnered with GE to make the SNECMA engine, which we use on our 37s. Those are very, very dependable engines. We love those engines. Boeing and Safran, this week, on Monday, signed a joint venture agreement to create a joint venture to make auxiliary power units between Safran and Boeing. So the office will be in San Diego, and they're going to announce their plans for manufacturing plants at some point in the future. So think about what that might mean and what kind of history Safran already has. So I foresee that there will be more interaction between our companies and our countries going forward into the future, but I'm excited to see what that will become. Over here.
So how do you see Mexico in the next 10 years regards aerospace? How are you looking at all these events, and how do you see that Mexico will be on the next 10 years?
Well, the one projection that I showed early in the presentation showed something like $4.5 billion worth of exports, aerospace exports coming out of Mexico last year. Of those, Boeing receives about $1 billion of those exports every year. So we're already heavily dependent on Mexico for a lot of those parts. The projections from FEMIA were that that would continue up to 11 billion, I think, was what their estimate was, or no, it was 8 billion in the near future. So I only see increase based on what we forecast the future to be. I would like to see some sort of a not just a gentle, gradual climb, but something more than that. And I think that's possible with the current environment.
Thank you.
Thank you. I have a curiosity. Why all your commercial airplanes starts with a 7?
That is a great question. The first aircraft, jet aircraft that Boeing produced that was a commercial aircraft was in the early 50s, and I've looked this up on the Boeing interweb, internal to Boeing, and I haven't found a consistent answer. I found a couple different answers, but one of the ones that I read, and as an engineer in training and practice, seemed to make sense to me, was that the trigonometric function for one of the sine or cosine is 0.707. So that may have, and that's the angle of sweep of the wings on the 707. So I like that one. So that's what I'm going to tell you. And then from that, it kind of established a pattern. So the next one was a 727, and then a 737. It sort of progressed. So we're almost out. There have been some people asking, well, what are you going to do once you use the 797 moniker? What's next? So I don't know. Someone that gets paid more than me will determine what
You
that
will
is.
turn with 4 numbers your airplanes, 7, 0, 1, 2, 3, whatever.
Maybe that's what we'll do.
Thank you.
Thank you. Jóvenes, algunas preguntas. ¿Quieren saber algo?
Hello. What role do the universities play on the company? What do they do, the students, for Boeing?
Dozens of things. Let me talk a little bit about a lab that at the University of Washington, which is just a few miles away from Boeing Field where I work. That's an old university. Someone from my department decided he wanted to have a research lab there, partly because it's a cool place, partly because he's a graduate from University of Washington. But he went and talked to the university. He went and talked to the university and asked them if they were interested in starting a laboratory. So they found some space for him. He started a lab there. He got some Boeing funding. He got some of their aerospace engineering students, and they started working on a couple problems for Boeing. So they funded that at a few thousands, or $20,000 or $50,000 a year, and they worked very closely with BR&T engineers from Boeing to develop a process or to build a part or to figure something out. And once that was done, we had a relationship with those students. Some of those students came to work for Boeing. And then we rotated other engineers through that lab. And now that lab gets funding every year. We send a few problems in there to be solved, and we work very closely with them. So we work with hundreds of universities around the world, and then we have maybe 10 strategic universities that we work even more intensely with and more completely. You may have heard of Massachusetts Institute of Technology, MIT. We are building a research center on their campus, helping them fund that. And so that's going to house a lot of our research and a lot of their students going into the future. So those are the types of relationships that we have with universities. One thing I failed to mention, some of my colleagues at Boeing just recently initiated a relationship with SETIS University in Mexicali. So we are starting to fund them with a little bit of money to help them develop their project and their programs and their lab there. And we're hoping to get in there and talk to them and see what they're doing and seeing maybe what the next step is. So that's one way forward, working with universities.
Thank you.
Any other questions?
Hi, good morning. In your opinion, what's the industrial infrastructure that is needed in Mexico for the aerospace industry growth?
Well, that's the $1 million question, isn't it? There are people that know more about that than I do, but first of all, capacity. If businesses are already operating at 90% of their capacity, then it's difficult to take on more work. Relationships with your suppliers, so people that bring you raw material, that can be a limiting factor. Good people who are trained, who know what to do, how to run a machine, how to write programming, how to write code, how to do design work. Those are all things that are part of the infrastructure, and that's not something you can necessarily go out to a store and say, I need 10 engineers today. You have to put them in the pipeline, and it takes some time to develop that. So human resources, production capability, and then the capability to get those products to the customers. quickly and safely without damage. Those are all needed. And then I think in various countries around the world, the government has played a role in fostering those relationships and making it easier for aerospace companies to do business with many different methods and ways to do that. Those all help build the infrastructure of an area. I'm sure you probably have people, companies here that could do studies for a particular industry or a particular company about what's needed for next steps and stages of growth. I hope that helps. Bill? Christian? How much time do we have? Okay. One more question, if there's one more? I see a hand up.
How can a Mexican student make an internship or something related about the aerospace industry in your company? Do you have any program or something related?
Let me find out the answer to that question. In my group, there's someone who has responsibility for our relationships with those strategic universities. And we work with those universities to identify and provide internships for some of those students. I think that's something that we would really like to do. So we may be talking with Juan Carlos? Later today with CETIS or maybe some other universities to see what we can arrange for that to progress forward.
Yeah, thank you very much, because we are very interested in the aerospace industry and make some research and some investigation to increase.
One of the things, I've worked on the research side for many years, and we would see intern students come maybe in their junior year and work with us. And then they're following their senior year, they come back and maybe work in a different department at Boeing, a different area of research. And sometimes they come back a third and a fourth year in their graduate programs, master's programs or PhD programs, and see other areas. And then they've had already a good kind of a view with what Boeing does in various areas. Sometimes we bring those people back in and they start working for Boeing. So I think that's another reason why we're very excited for the future, because there's all kinds of possibilities like that that we're just beginning to explore. Thank you for your time today. Appreciate the opportunity to be here with you.